I have here a picture of our WebLock Expert system. This is actually from the live system, and it's also looking at data from the training rig. So this is data on a previous run here. And you can see this is the same principle, that we get a point, in this case every few minutes, because it's from the test rig. On a real live situation, we'd probably go for once every hour or so for a detailed measurement point. And then we would take the trend of particular frequency bands in here. So this particular example relates to, if I can get it to show me, come on. There we are. So this relates to a ball pass frequency outer. So that means there's a defect on the outer race of the bearing. The bearing we have in this machine has got a defect built into it so that we can see this effect. So that's in the envelope spectrum, which is slightly more detailed analysis that's gone on there. But when we have a signal from a new signal coming in, and I've got one here that was transferred across earlier, because you don't want to be watching all the various transfer mechanisms. But we can take that signal directly into our source data, and then we have it here visible on the screen. And that file, if I just make that a little bit bigger so you can see it, we've got the time signal there. And actually the file contains all the channels from the test rig. So I can add in more channels, and you can see in certain channels these large spikes that are coming from our defect on the bearing. So we've got a lot of tools behind here, so we can put in the bearing frequencies. We've got cursors, we've got 3D waterfall plots, for example, which can help us to see what's going on, see how things are changing in time, and get into the detailed analysis of the data. So that's WebLock Expert. Just to say a little bit more about how that all goes through. If I go back to my earlier example, we have a series of different frequencies set up which relate to specific issues on a machine. They may be unbalance or misalignment, or there may be specific bearing problems or specific gearbox problems. And between those, we will get a number of these trends that come up. And then if any of these go into an alarm or an alert area, then we can go into a more detailed analysis and generate some information about what needs to be done to fix the machine before things go too badly wrong. So that's our more detailed package. It's very much process-based, so that if we have a lot of data to go through, we focus very quickly onto the data with the alarms coming up. So what you can see here is that all the different alarm messages that come in are related to a severity, and we can decide on that which one we're going to look at first, and it allows us to get through a lot of data in any given day. But then the tools behind it, the time signal analysis, the spectrum analysis, and the envelope spectra allow us to get into the details of what's going on the machine so that we can support predictive maintenance.